Hi there. So just wrapping up what we know now about the model of the atom. In the very beginning of our understanding of what an atom was, there was always the idea that there was a nucleus. But there was very little information on where those electrons were located. And the man who figured out where that there was such thing as a nucleus was a man by the name of Ernest Rutherford. And he proposed the nucleus and then basically said the electrons could be anywhere as long as they were outside of the nucleus. And so the analogy of that is very similar to this ramp. If you were going up this ramp, there's really no rules about where you could be. You could be, here, or you could be 1 centimeter, 1 millimeter, 1 nanometer higher up on the ramp. There's nothing that says, or there's no rules about where you need to be. And that's the difference between Rutherford's model and what we now have as the Bohr model, where Bohr's model was very similar to these latter pictures, that an electron can only be at these very specific energy levels. So if you are on this ladder, you can be here, or you could be on the next rung up, but you can't be in the middle. The ladder on the right is just actually a more accurate picture because as you get further from the nucleus, the energy levels or the rungs on the ladder become closer together. And for an electron to climb up one rung of the ladder, or when an electron falls back down one rung on the ladder, what that electron emits is a quantum. That's the smallest amount of energy that can be released or absorbed. And all of these statements are backed up by that experimental evidence that we saw with the atomic emission spectra. There was one major problem with Bohr's model, though. He had, and we didn't go into this, but mathematical calculations to predict the amount of energy released when an electron went from, let's say, the 4th energy level to the 2nd energy level. And he was absolutely right. And if you're able to make a mathematical prediction and then it is proven true by actually taking experimental measurements, it means that your model must be fairly accurate. And it was. The one problem is that it really only worked for hydrogen. So he was able to predict exactly the amount of energy released when an electron fell back down. Energy would be released, and it only worked for hydrogen. It didn't work for any other element. And that led people to believe that, well, his ideas and concepts must be at least partially right, but they just are not the full answer. And that's where we're going next. What is exactly the full answer? What is the answer to the question, where are the electrons in atom?